Oh, how's it going, everybody? Good afternoon. At least it's afternoon here. It's 4:06 as I start to teach this. In this video, we are going to talk about lesson 6.1, and we're going to talk about a little bit of exponential growth and decay. In the last two videos that you received for the last 2 weeks, we focused on exponential growth for one video, exponential decay for another video. Now we're going to put them together, and there's going to be one added element. If you look at this equation that we're about to graph, the difference is there's a number in front. You have this number with your exponent. That hasn't changed. Now that number right there is called your base. That's called your exponent, and this is out front. We kind of call that a coefficient, or we can, there's other names for it, but we're going to try to keep it simple right now. So there is a number out there, and that adds a little bit of difficulty, but not a lot. And the same goes for this one. Here's a base of 5, exponent still x, and we got this coefficient out front as a 2. So we're going to make our table, we're going to graph, and we're going to adhere to the rules we've already established in the previous videos. And I'll kind of talk about those as we go. It is incredibly important as we start to make our chart. Now you can see I already put 0 in the chart. I already put a 0 in this chart for when we get to example 2. That's where we always start with 0. Do not go 3 times 2 is 6, 6 to the power. You're disregarding the order of operations. Exponents take precedent, then multiplication. So you will do 2 to whatever power we're doing, then times 3. That's always second. Times 3 is second. Okay, so here we go. If we put the 0 in, 2 to the 0 power is 1. 3 times 1 is 3. So in a minute, the first point we put on this graph will be 0, 3. We'll go to 1 next. Now remember, right now as you see this, we're getting numbers that are big. Well, 3, this next number is going to be bigger. We're shooting for a number in this column to be somewhere in the neighborhood of 10 so that we can graph it easily, but we want it to be, 10's good. I scaled this 10 high just in case. So if I put the 1 right there, 2 to the first power is 2. 3 times 2 is 6. So I'll go another number, 2. 0, 1, 2. 2 to the second power is 4, times 3 is 12. Now, I'm going to write that, and I'm going to plot those points, and I don't quite have enough room here, but I kind of sort of do. You'll see what I mean. I would do this in class even if I didn't scale it enough. But anyway, here we go. 0, 3 is right there. 1, 6 is right there. 1 over 6 up. And then we have 2, 12. Now, right there is 10. So I can sort of fudge it and say, hey, it's right up there. So you get the idea. It's kind of high up there. Now, that's big enough. That's past 10 a little bit. It works for us. Now I'm going to go to the negative exponents. I'm going to go to negative 1. Now, I explained this a little bit before. It would be, in the previous videos about how negative exponents work, so you can refer to that. You can do it on a calculator. You say, again, I've said this before, if you don't have a calculator, you have downloadable calculators either on a smartphone or on your Chromebook. Desmos is one of the most popular. You have a way to get a use of a calculator. Anyway, 2 to the negative 1 power is a half. 3 times 1/2 is 1.5. I usually like a number a little bit smaller than that. Like I like it to be smaller than 1. So I'm going to go 1 more. Negative 2. 2 to the negative 2 is 1/4 or 0.25. And 3 times 0.25. Suppose I don't know that. Okay, 3 times 0.25, 0.75. That's smaller than 1. And I like that answer. So then I'll plot those two. Negative 1, 1.5 up. Negative 2, only 0.75 up, just small. We've seen this curve before. We do not cross the x-axis. And we curve up here, and this would continue, go right through our note, right through our title, and on up exponentially. So there's that. Exponent first times 3 second. Okay, continuing that over here. We start with the 0 power again. 5 to the 0 power is 1 times 2 is 2. So the first point in a couple of minutes will be 0, 2. If I go to 1, going to notice something kind of important here. 5 to the first is 5 times 2 is 10. I'm already large enough. I'm to 10. Just, you can see, if I were to go to 2 next, 5 to the second is 25 times 2 is 50. Yeah, I don't think I'm going to plot 2 comma 50. Okay? Go to the negative exponents. 5 to the negative 1 is 1/5, also known as 0.2. And 2 times 1/5 is 2/5, or 2 times 0.2 is 0.4. So we're already small enough here, and we're good. So really short compared to that over there. You know, I got 5 points. I got everything I needed in 3 points. I started with 0 like I was supposed to. The first positive number got me to 10, and the first negative number got me small. So plot those points. 0, 2, 1, 10, and negative 1.4. And there we go. Again, try, don't cross the x-axis. Show like you're hovering right there. And then this takes off exponentially speaking. So there you go. That's not a ton different from the weeks before, but just so you understand how to do those numbers that are out front, those coefficients, and how you handle them. I'm going to pause a minute. I got one more example I'd like to discuss. Okay, so here we go, back with example 3 now. You can see, if you remember in example 1, the base number that was sitting right there was a 2. Example 2, that base number is a 5. Now, if you recall us talking about the last video, if that number is bigger than 1, so 2, 3, 4, 5, you get that growth pattern which from left to right grows. Now that number, for this example, is 1/3. Less than 1. Still positive, but less than 1. We should expect a decay, a down from left to right. And anyway, so here we go. And 1/3 is not the friendliest fraction to work with, so, you can work with parentheses and all that on your calculator and make this happen. And I might even rely on my calculator a little bit to help me. First of all, 0 power. Remember, you do the 1/3 to the power, then times 5. Okay? 1/3 to the 0 power is 1, times 5 is 5. So the first point in a couple of minutes will be 0, 5. Put in 1. Or 1, excuse me. 1/3 to the first power is 1/3. 5 times 1/3 is 5/3, which is about 1.7. 1.6 repeating, actually. We'll call it 1.7. You can see the numbers are getting smaller. I like a number smaller than 1. So I'm going to go 2. Now, this is getting where it's not really super fun, but I can tell you this much. 1/3 to the second power is 1/9. Now, you don't have to know that. You can just do 5 times 1/3 to the second. And you can see on the screen how I type that in. Okay? And when I hit enter, I get 0.5 repeating, which rounded off will just be 0.6. So there's my number smaller than 1, which means now, see, and we expect that when it's exponential decay, as these numbers go up, these numbers go down. So now I'm going to go to my negative exponents. -1. And this is going to give us something rather shocking, and we're going to have to work with it a little bit. First of all, 1/3 to the negative 1 is 3. Times 5 is 15. We got quite a large number right off the bat. And even though I'm not going to graph it exactly, I'm going to fudge it a little bit because I need that number on there somehow. So 0, 5, 1, 2, 3, 4, 5. 1, 1.7 is like right there. 2.6 is like right there. Then negative 115. Now I only scaled this up to 10 again, so I'm just going to go like this. I just put a point right at the top of my board. But I need something there to kind of, I mean, this is okay, but you just see how that's really taking off. So think about the fact that this is way up here, comes down through here, and hovers. Okay, so that's that, people. That's the kind of assignment you're going to have this week. I'm probably going to give you a few, the last 2 weeks have been like 4 problem worksheets. Probably going to do like 6 questions this time just because I just want you to make sure you get the hang of it, and watch the examples, and I think you can totally handle this. All right, so good luck when you go to do this. We'll see you next time.